Anyone please unmute yourself and let me know that whether my slides are visible or not.
Yes, sir, visible.
Okay, thank you. So, good evening to all of you. So, let us start the class from where we have left behind. If you remember, in the last class, we have solved few problems related to friction. In continuation with those problems, let us solve the next problem. So, this is the sixth number problem. So, just read the problem. Problem is two blocks of weight W1 and W2 are connected by a string. You can see that this is your block W1 and this is your block W2. Both are connected by a common string, and that string is making an angle theta 1 with respect to horizontal from the first block. Find the magnitude and direction of the least force P that should be applied to the upper block to induce slipping. Take coefficient of friction for each block as mu. So what has been given in the problem that that means on this block, that is on the second block, that is W2 block, force P has been applied at some angle theta with respect to the horizontal. What you need to find out, what you need to find out is, you need to find out the least force or the minimum value of force P such that slipping will take place in the entire system. And slipping will take place, by that line I mean that the body will start to move or the entire system will be in motion. So yes, so basically what is given, two blocks are given, both the blocks are having weight W1 and W2 which is acting on the center of gravity of the both the block, and both the blocks are kept on a rough horizontal plane. Block W1 and the second block, that is whose weight is W2, both are connected by a common string, and that string is making an angle theta 1 with respect to the horizontal from the first block. So on the second block, force P has been applied at some angle theta with respect to the horizontal. So you need to find out what? You need to find out the minimum value of this force P in order to induce slipping. And by the term called induce slipping, I means you have to find out that minimum value of force P after the application of which the entire system will move. That is what you need to find out. So is the question clear to all of you? Any doubt in understanding the problem?
No,
Please
sir,
let
no
me know.
doubt.
Okay. So others, anyone from the electrical department, if you can respond whether the problem is clear or not.
Yes, sir.
Okay. So since we want to find out the value of force P, so the very first step, we all know, we are doing it from past many weeks, that we have to draw the free body diagram of both the block separately. So this leftmost diagram is the free body diagram of the second block, and the rightmost diagram is the free body diagram of the first block. Free body diagram of the first block. So if I draw the free body diagram of the second block, what I can say, that weight of the block, that is W2, acting vertically downward from its center of gravity. Since the block is kept on this horizontal surface, so the surface will give a normal reaction to the block in vertically upward direction. Say this normal reaction is nothing but N2, and since due to this application of force P, I can see that the entire system will move in negative x direction. So in between this horizontal surface and the block W2 at the point of contact, what will act? Frictional force will act, and by the law of friction I know that frictional force will act in the opposite direction to the direction of motion. So this frictional force is nothing but mu into normal reaction. Mu is your coefficient of friction into normal reaction is nothing but N2 for the second block. Okay, and what else? That is your force P is acting on this block at some angle theta. This angle is theta. Then definitely this force P will have two components. This component will be P cos theta, and this vertical component will be P sin theta. Now this block, that is the second block, is connected with the first block with this string. So this block will exert some tension on the string. Say that tension is T. If this angle is theta 1, then I know by the property this angle will also be theta 1. Fine. And this is your final free body diagram of the second block. Any doubts in the free body diagram of the second block? Any doubt is there in understanding regarding the FBD of the
Sir.
second block?
No,
Hello.
sir, not yet.
Okay, okay, fine. I think somebody is joining in. Let me make them join in. Okay, okay. So this is the FBD of the second block. Similarly, I can draw the FBD of the first block also. Let us draw it. Weight of the block W1 acting vertically downward. This block is in contact with this horizontal surface. So horizontal surface will give a normal reaction to the first block vertically upward, which is nothing but N1. Now this block, that is the first block, is connected with the second block by a common string. So this block will exert or will give some tension to the string. Let this tension is nothing but T, and since this tension is making an angle theta 1 with respect to horizontal, so I will have total two component of this tension. This component will be T cos theta, and this vertical component will be T sin theta. Okay, and since the motion of the first block is in negative x direction, so at the contacting surface point, contacting point is which point? That is, contacting point is the point between the contacting surface of this horizontal surface and this block. At this particular point, friction will act opposite to the direction of motion of the block, which is nothing but mu times of normal reaction, and normal reaction for the first block is N1, and it is given in the problem that coefficient of friction for both the surface, that means for this particular surface as well as for this particular surface, is same, that is mu. So this is your FBD of the first block. Any doubt regarding the free body diagram of the first block? Hello.
No, sir, no doubt.
Okay, okay. Anyone from electrical people, please respond. So far, whatever I have told, whether it is clear or not.
Yes, sir, clear.
Yes, sir. Okay. So next is we have to write down the equations of equilibrium, because how you will find out the value of force P? You have to use the equations of equilibrium, that is summation of fx equal to 0, summation of fy equal to 0, and if possible summation of moment equal to 0. But we will use that moment if it is required in the problem. If it is not required, we won't be using it. Fine. So let us first write down the equations of equilibrium for the first block. and that too summation of all the forces along x direction is 0. So if I see the free body diagram of the first block, I can write that is along x direction, that is minus t cos theta 1. This will be minus t cos theta 1. This is plus mu n1 is equal to 0. That is mu n1 minus t cos theta 1 is equal to 0, which is your equation number 1. And if I write summation fy equal to 0, what I can write? I can write that plus t sin theta 1 plus n1 minus w1 equal to 0. Check it. That is plus n1 plus t sin theta 1 minus w1 equal to 0, which is equation number 2. Any doubt in the equations of equilibrium for the first block, that is equation number 1 and equation number 2?
No, sir, no doubt.
Okay. Same thing we have to do it for the second block also. So let us write down the equations of equilibrium for the second block. So first let us write down summation fx equal to 0. That means this is your minus p cos theta. This will be your plus t cos theta 1, that is minus p cos theta, plus t cos theta 1 plus mu n2 is equal to 0. Check it. That is plus t cos theta 1 minus p cos theta plus mu n2 is equal to 0, which is equation number 3. Summation fy equal to 0. For that, from the diagram I can write this will be your p sin theta 1, that is plus p sin theta plus n2 minus w, and this is your minus t cos theta 1 is equal to 0. See, plus n2 plus p sin theta minus w2 minus t sin theta 1 equal to 0, which is equation number 4. So is it clear? Equation number 3 and 4, that is equations of equilibrium for the second block. Any doubt so far? Any doubt so far?
No, sir, no doubt.
Okay, if I can get anyone response from electrical people side, please respond.
No, sir.
Okay,
No, sir.
fine. Okay, so if you see these four equations, equation number 1, equation number 2, third equation and fourth equation. So with the help of these four equations, ultimately I need to find out what? I need to find out the least value of force P so that slipping will take place in the entire problem. So but the problem is that if you see equation number, all these equations, that is first, second, third and fourth equation, in all together we are having total 6 unknowns: n1, n2, tension T, force P, theta 1 and theta. If you see clearly equation number 1, 2, 3 and 4, from these four equations you can see that there are total 6 unknowns: n1, n2, t, p, theta 1 and theta. I need the value of only p. I need the value of only p. So at present there are 4 equations and 6 unknowns. It is not possible to find out the values of these 6 unknowns by the help of these 4 equations. But what I can do is I can write any one term or any two term in terms of other terms. Yes or no? Then I can solve the equation. Yes or no?
Yes, sir.
Fine. So let us write down any one term or any two term in terms of other terms. For example, you can see at last I want the value of P. So let us write say n1 and n2 in terms of t, p, theta 1 and theta. Then we will have four equations, four unknowns. Easily we can get the values of all these 6 unknowns. So for that what I am doing is from equation 1, if you see equation number 1, what is the value? It is mu n1 minus t cos theta 1 equal to 0. In equation number 1, I am substituting the value of n1 from equation number 2. From equation number 2, I will get n1 how much? W1 minus t sine theta 1. Just substitute this value in equation number 1. When you substitute that value, you will get mu into n1. n1 is nothing but w1 minus t sine theta 1 minus t cos theta 1 equal to 0. If you solve this expression, you will get equation number 5. That is tension T is equal to W1 mu divided by mu times of sine theta 1 plus cos theta 1, which is equation number 5. Is it clear till equation number 5? Any doubt?
No, sir, no doubt.
Okay, so if you see from equation number 1 and equation, or by taking the help of equation number 1 and equation number 2, I have formed equation number 5, that is T is equal to something. Similarly, in the same manner, if I take the help of equation number 3 and equation number 4, again if I formulate tension T equal to something, then my problem is solved, because LHS of equation number 5 will be equal to LHS of equation number 6. We can equate equation number 5 and 6. Yes or no? So now what I am doing, I will be eliminating N2. That means by using equation number 3 and 4. So if I see equation number 3, what is the equation? It is t cos theta 1 plus mu times of n2 minus p cos theta equal to 0. So in equation number 3, I will substitute the value of n2 from equation number 4. So from equation number 4, I will get N2 is equal to T sine theta 1 plus W2 minus P sine theta. Just substitute this value of N2 in equation number 3. So equation number 3 will become T cos theta 1, T cos theta 1 plus mu times of N2 is how much? T sine theta 1 plus W2 minus P sine theta, which I have calculated from equation number 4, minus P cos theta equal to 0. Now if I further solve this equation, finally I will get equation number 6, which is tension T is equal to P times of cos theta plus mu sine theta minus mu times of W2, then this bracket is there. Again I am repeating, P times of in bracket cos theta plus mu sine theta minus mu W2, then this bracket is there, divided by mu sine theta 1 plus cos theta 1, which is your equation number 6. Now if you see equation number 5 and equation number 6, I can equate the LHS of equation number 5 with LHS of equation number 6. Why? Because LHS is same in both the two equation. Yes or no? Hello.
Yes, sir.
Fine. So let us equate equation number 5 and equation number 6. If you equate equation number 5 with equation number 6, finally you will get this value, that is W1 mu divided by mu times of sine theta 1 plus cos theta 1 is equal to this particular value. Okay, that is this value, that is W1 mu divided by mu sin theta 1 plus cos theta 1 is equal to P times of cos theta plus mu sin theta minus mu times of W2 by mu sin theta 1 plus cos theta 1. Now if you see this expression, denominator of both the side is same. So you can eliminate mu sin theta 1 plus cos theta 1. Okay, if you eliminate, finally your equation is W1 times of mu is equal to P times of cos theta plus mu sin theta minus mu times of W2. Okay, so what you do, you keep P this side and bring these particular terms this side. When you do it, finally you will get expression like this. If you solve it, you will get expression like this. That is, P is equal to mu times of W1 plus W2 divided by cos theta plus mu times of sin theta. Is it clear so far? Any doubt?
No, sir, no doubt.
Okay, okay. So, see, now what I need to find out? I need to find out finally the least force P, that means minimum value of force P. So you can see that the expression of P is mu times of W1 plus W2 divided by cos theta plus mu sin theta. Okay, if you have to make P minimum, for that you have to make the denominator of RHS maximum, then only P will be minimum. Yes or no? Hello.
Yes, sir.
If you want to make P minimum, P will be minimum because P is dependent on theta. If you see the problem, P is dependent on theta. If you can increase the value of theta, you can decrease the value of theta. So with increasing and decreasing value of theta, your P will change. If this is the case, this is your expression of P, and in this expression of P, theta is coming in the denominator part. So the denominator part has to be maximum if you want to minimize P. Fine. But we know that angle of friction is nothing but given by tan phi is equal to mu, or phi is tan inverse of mu, where phi is what? Angle of friction. So I can replace this mu value by tan phi. So I can write P is equal to tan phi in bracket W1 plus W2 divided by cos theta plus mu sin theta. Now tan phi, I can write it as sin phi by cos phi. Why I am doing it? Because if you see the denominator part, in denominator the expression is in terms of sine and cos. So I have to convert this tan in terms of sine and cos. So finally your P becomes P is equal to sin phi by cos phi into W1 plus W2 divided by cos theta plus sin phi by cos phi into sin theta. Okay. Further, if you solve this expression of P, you will get sin phi in bracket W1 plus W2 bracket close divided by cos phi. That is this term. That is this term divided by this particular term, in this term you can write like this, that is cos phi is equal to cos phi plus sin theta sin phi. I can write this denominator like this. Then that means I can write sin phi W1 plus W2 divided by cos phi divided by this expression cos theta cos phi plus sin theta sin phi divided by cos phi. Fine. So when you change the sign of division by multiplication, this cos phi will come in the numerator part, and this cos theta cos phi plus sin theta sin phi will come in the denominator part. And I know that this cos A cos B plus this part, this is cos theta into cos phi plus sin theta into sin phi, is nothing but cos A cos B plus sin A sin B, which is nothing but cos of A minus B, that is cos of theta minus phi. So finally this cos phi will get cancelled out, and you will get the expression of P as W1 plus W2 into sine of phi divided by cos of theta minus phi, which is equation number 6 dash. Any doubt till equation number 6 dash?
No, sir, no doubt.
Okay. So if I can get anyone response from electrical people side, please respond whether it is clear or
Yes,
not.
sir. Clear.
Okay. So ultimately what I want to find out now, see the entire expression of P, which is equation number 6, is either in the form of theta or in the form of phi. But if you see equation, this particular expression of P, this particular expression of P, the entire expression was not in the form of theta and phi. This mu was present. In order to replace this mu in terms of theta and phi, we have did this procedure. Okay. Now, if you want to minimize the value of P, what you want to do? You have to maximize the denominator. And you know that how you can maximize the denominator. That means the denominator term consists of cos term, and I know that maximum value of cos is 1. That means this entire term, that is cos of theta minus phi, it is maximum when the entire term is equal to 1. That means I can write cos of theta minus phi is equal to 1, or I can write cos of theta minus phi is equal to 1 is nothing but cos 0. Cos get cancel out from both the sides, or I can write theta minus phi is equal to 0, or I can write theta is equal to phi. That means when the value of theta, when the value of this theta becomes equal to phi, that is angle of friction, then the movement of the entire system will take place. So that minimum value of force P is how much? Just evaluate either theta by phi or phi by theta in equation number 6. You will get the minimum value of force which is required to move the block, and that minimum value of force is W1 plus W2 into sine of phi divided by cos of, I am replacing theta by phi, that is cos of phi minus phi. Phi minus phi is 0, cos 0 is nothing but 1. So finally your expression becomes P minimum is equal to W1 plus W2 times of sine phi, or W1 plus W2 times of sine theta. So that means this much amount of minimum force you have to apply on this second block at some angle theta, then only the entire system will move along negative x direction. So this is the complete solution of this problem. Are you having any kind of doubt with this problem? Any doubt is there?
No, sir, no doubt.
Okay. Just practice such type of problems from the book. I know very first time you may feel that it is little bit difficult, tricky, but let me tell you it is not at all difficult and tricky. If you know how to make the free body diagram and simple mathematics, that is how to eliminate one part into another part, how to equate it, everything, then the remaining thing is easy. Okay. So should I move to the next problem?
Yes, sir.
Okay, fine.
Yes, sir.
Seventh problem. Okay, read the problem. The problem is two blocks of weight 200 Newton and 300 Newton are connected by a string passing over a frictionless pulley resting on rough surfaces as shown in the figure. Let us see the figure. This is the figure. The second block, this is the second block which is kept on an inclined plane of angle 60 degree, and the first block is kept on a rough horizontal plane. Both the block are connected by a common string through a pulley, frictionless pulley. Okay, and weight of the block is given to you, that is weight of the first block is 200 Newton, Weight of the second block is 300 Newton. Fine. Coefficient of friction for both the surfaces is mu equal to 0.25. That means the surface which is in contact between the second block and this inclined plane, as well as between this first block and this horizontal surface, for both the surfaces coefficient of friction value is same, that is 0.25. Fine. Find out the minimum value of force both in magnitude and direction for the motion to impend. Also find the tension exerted by the string. You can see that the force P is applied at some angle theta from the first block with respect to horizontal. What I need to find out? I need to find out the minimum value of this force P as well as direction. Direction means theta. I need to find out so that motion of the entire system will start. Everything is same, the same thing we have did in the last problem also, and the same thing we will be doing it in the next problem also, only the figure has been changed. Okay, this is the first part. And what is the second part? We need to find out the tension exerted by the string. Since the first and the second block is connected by a common string passing through a frictionless pulley, what will be the tension exerted by this common string T? That also I need to find out. Is the problem clear to all of you? Any doubt in understanding the problem?
No, sir, no doubt.
No,
Okay,
sir.
fine. Again the same process. Let us draw the FBD of both the blocks separately. For block number 2, this is my block number 2. Okay, weight of the block, that is 300 Newton, acting vertically downward. Fine. Now this block is in contact with this inclined plane. So this inclined plane will give a normal reaction to the block in this direction. Say that is nothing but R2. Okay, let us write it as R2. If this angle is 60 degree, definitely this angle will also be 60 degree by geometry. Then this W will have two component. This will be your W cos 60 and this will be your W sin 60. Since this block is connected by a common string T, so this block will exert some tension to this string in this direction, say this is T, and there will be a frictional force at the contacting surfaces. That means contacting surfaces of the inclined plane and the block. Now I can see that force P is applied in outward direction to block, to the first block. That means the entire system will move in this direction. If I talk about the second block, motion of the second block will be in this direction. So frictional force will be in this direction. That is mu times of R2. And this is your final FBD of the second block. Similarly, we can draw the FBD of the first block also. Weight of the block, that is 200 Newton, acting vertically downward. This block is kept on this horizontal surface, so horizontal surface will give a normal reaction to this block in upward direction, that is nothing but R. Now this block 1 is connected with block 2 by a common string, so this block 1 will exert a tension on this string, say this tension is nothing but T. From this block force P is applied at some angle theta. This is your force P at some angle theta. Now this force P will have two component. This will be your P cos theta and this will be your P sin theta in upward direction. That means this is my P cos theta and this is my P sin theta. and since the block is moving in this direction, so at the contacting surfaces I will get a frictional force, that is nothing but mu times of R1 in negative x direction. So this is your final FBD of the first block. Is it clear? The two FBDs of block 1 and block 2. Any doubt in this? Any doubt?
No, sir, no doubt.
Okay.
No, sir.
So same process. Again, I have to write down the equations of equilibrium for both the blocks separately, and let's see whether easily we can get the value of P or not. If not, then we have to eliminate some values, what we have did in the last case. Okay, but if you see, the second block is kept on an inclined plane, of 60-degree angle. Then your x-axis for the second block will be this. Will be your x-axis, and this will be your y-axis. Okay. So if I write summation fx equal to 0, what I can write? I can write plus t minus 300 sine 60 minus mu 2 R2 is equal to 0, or I can write T is equal to W2 sine 60 plus mu 2 R2. W2 is given in the problem, that is 300 Newton, so 300 sine 60 plus mu 2, since coefficient of friction is same for both the contacting surfaces, that means mu 1 is equal to mu 2, which is equal to 0.25 times of R2. Sine 60, multiply sine 60 with 300, you will get the value as 259.80. So finally you will get equation number 1, which is nothing but T is equal to 259.80 plus 0.25 times of R2. Is it clear? Any doubt so far?
No, sir, no doubt.
Okay. So similarly we can find out summation if y equal to 0. Similarly, we can find out summation if y equal to 0. That is, if I find out summation f y equal to 0, then I can write plus R2 minus 300 cos 60. That's it. No more values are present along y-axis. So I can write R2 minus W2 cos 60 equal to 0, or R2 is equal to W2 cos 60. W2 given in the problem 300 into cos 60. So you will get the reaction force R2, which is 150 Newton. Once you get the reaction force R2, you can substitute the value of R2 in equation number 1. Finally, you will get the tension of the wire, that is 259.80 plus 0.25 times of R2. R2 is 150 Newton. So finally, you will get the tension in the string is nothing but 297.3 Newton, which is one of the part of this problem. Any doubt so far?
No, sir, no doubt.
Okay. Electrical people, please respond whether it is clear or not.
Yes, sir. Clear.
Okay. So this was one of the part of the problem, that is you need to find out the common tension present in the string or wire. Next is I need to find out the value of force P. Fine. Okay. So now let us write down the equations of equilibrium for the first block. That is summation fx equal to 0. If I write summation fx equal to 0, I can write that P cos theta. This is your plus P cos theta minus T minus mu 1 R1 is equal to 0. See, P cos theta minus T minus mu 1 R1 is equal to 0, or I can write P cos theta minus tension, already we have found out, just evaluate, that is minus 297.3 minus mu is given in the problem, that is 0.25 times of R1 is equal to 0, which is say equation number 2. Now if I write summation Fy equal to 0, I can write plus R1 minus W plus P sine theta is equal to 0. Let us check it. That is the plus r1 minus w1 plus p sine theta equal to 0, or I can write r1 is equal to w1 minus p sine theta. W1 is given in the problem, which is 200. So finally I will get r1 is equal to 200 minus p sine theta. Now I can substitute this value of r1 in equation number 2. Let us substitute, that is p cos theta minus 297.3 minus 0.25 times of r1. R1 is nothing but 200 minus p sine theta equal to 0. If you solve this expression, finally you will get p is equal to 347.3 divided by cos theta plus 0.25 times of sine theta, which is the third equation. Is it clear so far till the third equation?
Yes, sir, clear.
Okay, fine. So now I can see, now if you see equation number 3, the entire equation is in terms of theta. That is what I want, because the value of p is dependent on theta. You can increase or you can decrease the value of theta. If you see in this equation number 3, the entire value is in terms of theta. So if you want that this p should be minimum, for that the denominator part is maximum, and the denominator part is nothing but combination of cos and sine theta, that is cos theta plus 0.25 sine times of sine theta. Fine, you have to maximize this denominator part. How you can maximize? If you differentiate this denominator part with respect to 0, you will get one value of theta, and that value of theta, if you put in equation number 3, you will get the minimum value of force P. That is your requisite answer. Yes or no? That means I have to differentiate the denominator of equation number 3 and equate it equal to 0. That is d by d, that is d theta of cos theta plus 0.25 times of sin theta should be equal to 0. Is it clear? Did you understood this part? This particular part?
Yes, sir, clear.
Okay, so let us differentiate it. Once you differentiate it, you will get the value of theta as 14.03 degree. This is the second part of the problem. It has been told in the problem that you have to find out the value of force P as well as the direction. So direction is how much? That means you have to apply force P at an angle of 14.03 degree from the horizontal, then only the entire system will move. Okay, so once you get the value of theta, substitute this value of theta in this equation number 3 of P, that is P is equal to 347.3 divided by cos of 14.03 plus 0.25 times of sine of 14.03. Just solve it, you will get the minimum value of force P, that is 336.93 Newton, that is, or 336.93 Newton. So these are the three parts which you need to find out in this problem, that is P minimum, theta, and the tension exerted by the string. Is it clear? Is the problem clear to you?
Yes, sir, clear.
Okay. Electrical people, please respond whether it is clear or not.
Yes, sir. Clear.
Okay, fine. So this was the problem which we have discussed so far. So one more last problem for today's class we will discuss, that is this eighth problem. Okay, you have did this problem in the first module itself when I was discussing the equilibrium condition of forces. The same problem you have solved in that part also, but the difference between that problem and this problem is that in this problem the contacting surfaces are not smooth. The same problem which you have solved in the first module, in that problem the contacting surfaces was smooth in nature, so we haven't considered the case of friction, but for this problem we have to consider the friction also into account. So let us read the problem. The problem is a horizontal bar 1 meter long and of negligible weight rest on a rough inclined plane as shown in the figure. If the angle of friction is 15 degree, determine the minimum value of x at which the load Q equal to 200 Newton may be applied before slipping impend. That means what is given in the problem? A horizontal bar is placed on two different inclined plane. End A of the bar is kept on a 30-degree inclined plane and end B of the bar is kept on a 60-degree inclined plane. On that horizontal bar, two forces are applied. One force is 100 Newton, which is at a distance of 0.2 meter from end A. Another force is 200 Newton, which is at a distance of say x meter from end B. Angle of friction is given to you, that means phi value is given to you, that is 15 degree. What you need to find out? You need to find out what will be the minimum value of x, or what will be the minimum distance at which you should keep this 200 Newton load from end B so that slipping will take place. So that means slipping will take place means this body will move from its initial condition. You need to find out that value of x. That means x will be at how much distance from end B so that the entire system will be in dynamic condition. This is what you have to find out in this problem, that is the value of x. Is it clear? Did you understood the problem?
Yes, sir.
Okay. If I can get anyone any response from electrical people side, please respond.
Yes, sir.
Okay, fine. So if you see, due to application of this 100 Newton load at zero point 0.2 meter, this horizontal bar will try to move down. If it is a try to move down, that means this end A will try to move in this direction and this end B will try to go down the inclined plane. Yes or no? Hello? Hello?
Yes, sir.
Fine. Why? Because see, at end A, angle of inclination is 30 degree. At end B, angle of inclination is 60 degree. If you increase the angle of inclination, the body will try to come down. That means you can see that this end B of the bar will move in this direction. Why? Because angle of inclination where this angle of inclination of this horizontal bar at point B is more as compared to the angle of inclination of the horizontal bar at point A, that is 30 degree. That means at point A, motion of the entire problem will be in this direction, and at point B, motion of the entire problem will be in this direction. Is it understood? Is the concept clear how the motion will take place?
Yes, sir.
Electrical people, please respond whether it is clear or not.
Yes, sir.
Okay, so now let us draw the FVD. Okay, just let me erase each and everything. Okay, fine. So if I draw the FVD of this horizontal bar, I can see that one load 100 Newton is acting at a distance of 0.2 meter. Another load 200 Newton is acting at a distance of x meter. Now since this horizontal bar is in contact at point A, so this inclined plane will give a reaction to this horizontal bar at point A in this direction. Say it is nothing but RA. Similarly, this inclined plane, the 60-degree inclined plane will give a reaction to this horizontal bar at point B in this direction, that is nothing but RB. So this is the final FBD of this particular problem. Is it clear so far?
Yes, sir, clear.
Okay, electrical people, please respond whether it is clear or not.
Yes, sir. Clear.
Okay, so if this is my RA, so if I extend this RA and if I extend this line, this angle given is 30 degree, this angle will be 90 degree, then how much will be this angle? It will be 60 degree. Similarly, this is my direction of RB. If I extend this horizontal line like this, and if I extend this RB like this is a triangle. This angle is 60 degree. This angle is 90 degree. Then this angle will be how much? This angle is 30 degree. Okay, that means if this is your RA, if this is your 60 degree, at this particular point this angle is also 60 degree. That means this RA will have two component. One component is RA cos 60, another component is RA sin 60. Similarly, if I talk about RB, if this is 30 degree, then definitely this is also 30 degree, and this is the direction of RB. Again, this RB will have two component. One component is RB cos 30, another component is RB sin 30. Is it clear so far?
Yes,
Any
sir.
doubt? Okay,
Yes, sir.
okay. So similarly, so we are done with the component of RA and RB, but we are left with the component of frictional force mu RA and mu RB. See, mu RA is in this direction. This is your mu RA. Okay, that is this is your mu RA. If this angle is 30 degree, then by geometry I know that this angle is also 30 degree. That means this mu RA will have two components. One component is mu RA cos 30, another component is mu RA sin 30. Similarly, if I talk about point B, this is your mu RB, this is your mu RB, and this angle is 60 degree. That means this angle given is 60 degree. Fine. That. So you will have two component. One is mu RB cos 60 and another is mu RB sin 60. Is it clear? The component of mu RA and mu RB? Any doubt?
No, sir, no doubt.
Okay. Electrical people, please respond whether any doubt is there or not in finding out the component of mu RA and mu RB.
Sir, no doubt.
Okay. So we have resolved all the forces. Now let us write down the equations of equilibrium. That is, first of all, let us write down summation of fx equal to 0. If this is the case, then I can write down all the forces along x-axis is equal to 0. That means plus RA cos 60, see, plus RA cos 60, plus mu RA cos 30, plus mu RA cos 30, minus RB cos 30, minus RB cos 30, minus mu RB cos 60, no other horizontal force is present, equal to 0. So I can write that the cos 60 is 0.5 times of RA plus, since in the given problem mu is not given to you, but you know that mu is nothing but tan phi, so just replace it, in place of mu replace it by tan phi. Tan phi into RA cos 30 minus RV into cos 30 is nothing but 0.866 plus again mu, you have to replace it by tan phi. So tan phi into RB cos 60. And in the given problem you see angle of friction is given to you, that is 15 degree, and this angle of friction is nothing but the phi value. So here in place of phi you can substitute 15 degree, here in place of phi you can substitute 15 degree and just solve this expression. If you solve it, you will get that RA is equal to RB, which is equation number 1. Any doubt till equation number 1?
No, sir, no doubt.
No, sir.
Okay, fine. So next is summation of all the forces along y direction is 0. That is summation Fy equal to 0. Let us write down summation Fy equal to 0 equation, that is plus Ra sine 60. See, plus Ra sine 60 minus mu Ra sine 30 minus mu Ra sine 30 plus Rv sine 30 plus Rv sine 30 plus mu RV sine 60 plus mu RV sine 60 minus 100 Newton minus 200 Newton is equal to 0. See, minus 100 minus 200 is equal to 0. Okay, again in place of wherever there is mu, just replace it by tan phi. That means here you have to replace mu by tan phi. Here you have to replace mu by tan phi. And since RA is equal to RV, substitute this equation number 1 in equation number 2. You can get the values of RA and RB, and that RA is coming out to be 204.91 Newton, and which is equal to your RB value. Is it clear so far? Values of RA and RB, how I have calculated?
Yes, sir.
Yes, sir.
Okay, fine. So see, for this problem, when you substituted summation fx equal to 0, you got one equation, Ra is equal to Rb. Secondly, when you substituted summation Fy equal to 0, you get the value of you got the value of Ra, which is 204.91 Newton, and that is nothing but equal to Rb. But what I need to find out in the question, I need to find out the value of x. That means you can see that summation fx equal to 0 and summation Fy equal to 0 will not yield the value of x, or will not give the value of x. So for this problem I have to take the help of the moment equation, that is summation of moment about any point is equal to 0. And for this problem, since I need to find out this distance x from point B, so let us write down the equation of moment about point B equal to 0. Then from this equation we can easily find out the value of x. Is it clear? Is it clear?
Yes, sir.
Okay. So did you understood that when or where I am using the moment and where I am using the summation fx summation fy equal to 0? Because this, you can see in this problem, by the help of summation fx equal to 0 and summation fy equal to 0, we will not be able to find out the value of x. So we have to take the help of third equation, which is summation of moment is equal to 0 about any point. And since we are interested about distance x, which is measured from point B. So that's why I am taking summation of moment about B is equal to 0. Write down, while writing down the moment equation, you will not take moment of the forces passing through point B, because definition of moment is what? It is force into perpendicular distance from the point of application of force. So the forces which are passing through point B, those forces will not have any perpendicular distances. That means if I talk about RB, I have one component, that is RB cos 30. This component I will not consider in my moment. I am having one more component, that is RB sin 30 in this direction. This particular moment of this particular force also I won't consider, because there is no perpendicular distance from point B. Fine. And if I check this array, again this array will have two component. Array cos 30 will be like this, and you can see this array cos 30 will pass through point B. Again we are not having any perpendicular distances, so we will not take this array force into account while calculating moment. But if I talk about, say, RA sine 60, this is RA sine 60. This force I will take in calculation of moment, because I am getting perpendicular distance, that is RA into this particular distance at point B. Similarly, if you talk about this mu RA, this mu RA is one component is your mu RA cos 30. Again, I won't take this into account while calculating the moment. Second component is like this, mu RA sin 30. I have to take this component into account in order to calculate the moment, because I am getting perpendicular distance like this. Fine. So in this way, we will write down the equations, that is the moment equation of equilibrium. Is it clear?
Yes, sir, clear.
Yes, sir.
Okay, so let us write down the moment equation, that is RA. That means this component I am taking RA sin 60 into this length about point B, and the entire length given in the problem is 1 meter. So RA sin 60 into 1. But whether it is a clockwise or anti-clockwise movement, because one either if we are taking clockwise positive, we have to take anti-clockwise negative. So can you tell me that this RA into 1 meter is creating a clockwise or anti-clockwise moment at point B? RA into 1 meter is creating which kind of moment? Clockwise or anti-clockwise moment about point B?
Clockwise.
Yes, if you hold point B, this RA into 1 meter will create a moment like this, that is clockwise moment. Here I have taken clockwise moment positive. So if I have taken clockwise moment positive, I have to take anti-clockwise negative. Or if I am taking anti-clockwise positive, I have to take clockwise negative. Okay. So RA sin 60 into 1. Next is moment of mu RA. Moment of mu RA. That is this mu RA. Again this mu RA. This cos component I won't take. I have to take this sine component, that is mu RA sin 60. The mu RA sin 30 into this 1. But see, this mu RA into 1 at point B is creating anti-clockwise moment. So I am taking it as negative. That is minus mu RA sin 30 into 1. Okay. Next is moment of this force, that is 100 into distance, perpendicular distance at point B, and overall distance is 1 meter. This distance is 0.2 meters, so this distance will be how much? 1 minus 0.2, that is 0.8 meters. So moment will be 100 into 0.8. Again it is creating what? Anti-clockwise moment, so negative. So you can see minus 100 into 0.8. Next is moment due to this force, that is 200 Newton, that is 200 into this much distance, that is 200 into x. Again it is creating anti-clockwise moment, so I will take it as negative. So minus 200 into x is equal to 0. If you solve this particular expression, you will get the value of x, and that x value is coming out to be 0.35 meter. That means what I can conclude from this problem? I can conclude that if I keep this 200 Newton force in downward direction at a distance of x equal to 0.35 meter from end B, then the entire structure will not move. It will be in equilibrium condition. So this is the final answer of this problem. Any doubt in this problem?
No, sir, no doubt.
Electrical people, please respond whether the problem is clear or not.
Sir, no doubt.
Okay, okay.